In this video, we'll take a look at how to perform operations on vectors in terms of I and j. When you're given vectors that are in terms of I and j, in other words, ai plus bj, adding and subtracting them is fairly straightforward. What you do is you take like components, the a parts and the b parts, and you add them or subtract them, whatever the case may be, whatever it is that you are attempting to accomplish. So what all of this mumbo jumbo here means is just take the like parts and combine them, and then rewrite the form of your vector into ai plus bj form. So it's very similar to working with complex numbers. It's how I like to think of it in my mind when I am working with vectors and adding them and subtracting them. That's kind of where my mind goes. So let's just take a look at two examples, one where we subtract and one where we add. So let's just say that I am given vector v equal to 7i plus 3j, and I have vector w as 4i minus 5j. And I want to add them and I want to subtract them. So first let's add them. So let's do that first. Let's add v plus w. So if I am going to add them, that means I'm going to add the a parts and I'm going to add the b parts. So that means I am going to take 7 plus 4 and put them together. And I am going to take 3 plus -5 and put those together. And I'm going to then attach them to their appropriate components, be it I or j. So 7 and 4 give me an 11i plus 3 and -5 give me a -2j. And then I'm just going to clean that up a little bit because I don't like to write two signs together. And that gives me 11i minus 2j. And there I've added the two vectors together. Now, if I want to subtract, let me give myself a little bit more room here. If I want to subtract v minus all right, so the downside of when you shrink that up, it makes your pen get really thick. All right, so v minus w. I'm going to do the same thing. I'm going to subtract like components. So it's going to be a1 minus a2 and put it with my I plus b1 minus b2 and put it with my j. Same thing. Just going to subtract this time. So I'm going to say 7 minus 4i plus 3 minus a -5 and put that with my j. And then I'm going to clean that up and I'm going to have 3i plus 8, because 3 minus a -5 is actually 3 plus 5j. So there's the subtracted form of v minus w. All right, so let's take a look at multiplication. Scalar multiplication with a vector that is in terms of I and j. I'm just going to take that scalar and I'm going to multiply it times each component. I'm going to essentially distribute it through. I'm going to multiply that scalar times the a component and times my b component and write the resulting vector. So let's just say I have the vector of, if v is equal to 7i plus 10j. And I want to multiply it times the scalar 8. So let's multiply times 8v. So first let's multiply times a positive, and we'll multiply times a negative and see what that looks like. So let's find 8v. So if I'm going to do that, I'm going to say 8 times 7 I, and I'm going to say 8 times 10 j, and that's going to give me 56i plus 80j. Gives me a new vector increased by a multiple of 8. So next, let's take a look at times negative 5. Let's multiply our vector times negative 5. So if I multiply my vector times negative 5, I'm going to do the same thing. I'm going to say negative 5 times 7 plus negative 5 times 10. And that's going to give me a negative 35i minus 50j. So giving me a new vector. So addition and multiplication of the vectors that are in terms of I and j, certainly nothing too difficult. We just follow the same rules that we've learned before. The 0 vector is a new vector that we haven't talked about, but the 0 vector is a vector whose magnitude is 0, and it has no direction. And when we express the 0 vector, it isn't just expressed with a 0 component for A and a 0 component for J. When we add a 0 vector to any other non-zero vector, the resultant is equal to the given non-zero vector. Up next, we're going to take a look at unit vectors, what they are, and how we can find a unit vector that has the same direction as a given non-zero unit vector.